Now we are going to move to the next point, that is, now we are going to fix the temperature 0 degree Celsius and we are going to increase the pressure. So what changes are going to happen in terms of phase that we are going to observe. So here we are in this line, dotted line, I have increased from this point to above. That is 1 atmosphere pressure at this point. We are increasing the pressure. Now what happens when if you are keeping the temperature fixed and you are increasing the pressure, right? So diagrammatically I am showing here one piston is there. So at this point you have both, like in equilibrium like ice as well as liquid also there. So ice and liquid also they are available, and this is the piston. Now we are going to increase the pressure. Increasing pressure means what? So pressure is inversely proportional to the increasing pressure means you are decreasing the volume. You are decreasing the volume because here your temperature is fixed. So you are decreasing the volume. So what you observe here? So if you reduce the volume, what going to happen? Right? Now you are pushing down to the container. So all ice that are going to get melt and form the liquid. So in this whole region it represents as a liquid. So whatever your ice that is going to convert to the liquid. So have you noticed this? After putting your higher pressure on your ice, it going to turn into liquid. This is very surprising, right? Means your volume, this phenomena we call it anomalous behavior of water. This is generally happens due to ice has lower density, right? Compared to water, ice have lower density and more volume. More volume than liquid water. Right? So because of this, after putting you are reducing the volume, so what will happen? Whatever ice that will will back to the liquid state. So because of this phenomena, we call it anomalous behavior of water. So as we are increasing the pressure, it will form as a only liquid. Only liquid. Fine. Now we are going to check the another condition. Now you are reducing the pressure. So you are reducing pressure means, so you are taking this piston in above. So what you are going to do? So you are reducing pressure means this is inversely proportional. You are reducing pressure means increasing the volume. So now your volume is got increased. If volume is increased, so everything will become the ice form. So this represent it forms ice. So as we go down at 0 degree Celsius, you will get the complete ice. So here it is in ice form. Okay. So here you will get the ice. So using this phase diagram, the curve OC is inclined towards the y-axis, that is pressure axis. So according to this, so dP by dt that indicates equal to negative. So slope is negative means you will get the depression in the freezing point. So at 0 degree Celsius, water get freeze, but at what pressure? At 1 atmospheric pressure. So this is important. And at 100 degree Celsius, water is get boiled. That is 1 atmospheric pressure. So if you change the pressure, your freezing point as well as boiling point will also will differ. Now we are going to see the another condition. Another condition is at higher pressure. Pressure at there 218 atmospheric pressure is there. Now we are going to change the temperature from -20 to the 374 degrees Celsius. So at -20 degrees Celsius, as you can see, it is in form your water is in the form of ice, that is in solid. So high pressure and as well as ice also there. So as we move from minus 20 degrees Celsius towards the 0 degrees Celsius, you are at one in the middle of one point, you will get the equilibrium. That is ice. That is equilibrium with the ice is equilibrium with the liquid. So at this point, your equilibrium case will be there on the fusion curve. So ice is also there and liquid also is there. So as we are further increasing the temperature slowly, you will get the only liquid. So at max like 374 degrees Celsius, the point A will come. That A is located on OA. The curve indicates that the vapor pressure curve. So where we get the another equilibrium. So that is liquid is equilibrium with the water vapor. So this indicates that the second equilibrium. So water you are providing the heat, that is completely utilizing to change the that heat is using to change the phase of the water system. So here from liquid phase it is going to vapor phase. So at 374 degrees Celsius we call it that is critical temperature, because above the 374 you will not get the any liquid. So you will get only vapor. 374 degrees Celsius and 218 atmospheres. So above this pressure and temperature you will get only water vapor. So this you should remember. So student can write down this. Now we are going to learn about the curve OB. So this curve is indicated as a sublimation curve. So on this curve you will have both equilibrium, which face ice as well as vapor. Ice as well as vapor. So both will be present on this curve. So that is in equilibrium. So we are going to take another condition, that is below 4.58 mmHg. So if you are reducing further the pressure, so you are lowering pressure means you are increasing the volume, that is inversely proportional. Now at minus 20 degrees Celsius, so you will have ice. But if you go further lower and lower value than 4.58 mmHg, so you will have only at certain point you will have only ice. After that you will have only vapor phase. So as we are increasing the temperature, now here we are increasing the temperature. So what effect is going to happen, that we are going to see here. So as we are increasing from minus 20 to so after certain time you will have only vapor. So ice is directly getting sublimed to the vapor because volume of the container. So you are moving piston so high, so your ice is not going in water phase, that is going only in vapor phase. So above 0.0075 degrees Celsius you will have only vapor. So above this pressure also you will have only vapor. So water will absorb in only vapor form as well. So from this curve you must understand. So now we are going to see the metaphase of the water system. Now take an example. Suppose you have water vapor and liquid, that is both are in equilibrium. We are taking this condition, curve OA. Curve OA. Now your point is there. So you suppose you have you at triple point. Now at this condition you are slowly reducing the temperature. If you are slowly reducing the temperature as well as the pressure, you will be having both water as well as water vapor. Both will be present. So at certain time, so this if you are extending the curve like O, and this is this dot curve we represent as a OA dash, right? So this is just opposite, so that's why I represented it as A dash. If you are reducing the both slowly, like pressure as well as temperature, you will have both are in equilibrium. Like water vapor as well as liquid. If you that system, if you shake it or physically pinch it by anything, that immediately everything will become the ice. So this is the state. Understand? So both have you seen any experiment like if water is there and vapor is also there and vapor pressure also is there, and suddenly if you pinch it, immediately everything turn into the ice. Like it's wake up kind of thing. So water don't remember I have to freeze. So in that way you can remember. So here slowly, like water will be so cold at certain pinch you will get the that solid. So that is extended. So this dash means that phase may not be changed, but certain physical movement you can get ice. So this indicates this OA dash curve indicates that the metastable state of water. So student can write down this. Now we are going to see the phase diagram by phase rule. Here from 0.0 this curve OC and OB, before that you will get only ice form, right? Only one phase is there. Only one phase is there, that is ice. So what is the degree of freedom here? Your F value will be, what is the formula? C minus P plus 2. So C component is always 1. So we have already mentioned component is 1. Phase is only 1 plus 2. So your degree of freedom is F equal to 2. So C O B, before this curve you will your degree of freedom will be always 2. So that system is called bivariant. To define any point between this value, you need two variables. That is, one is temperature and another is pressure. Right? Now, take another egg condition that is on this line, where both phases are present. That is, ice as well as liquid is present on this curve. That is fusion curve. So what will happen here? What is the phase degree of freedom here? That we have to calculate. So here degree of freedom at this point, equilibrium, F equal to C is 1 minus phase is 2 plus 2. So 2 will get cancelled. So your degree of freedom is only 1. So that system is monovariant system. So on this curve, suppose you want to you have to say the both ice and liquid are in equilibrium, then you have to tell only one either one quantity, either pressure or temperature. So suppose you have to tell then you can ask you have to tell only one variable, means suppose you have only one variable, that is your temperature is 0 degrees Celsius and both are equilibrium. Then what you have to say? So you know the pressure will be 760 mmHg, that is 1 atmosphere. So this you can conclude from that. So you no need to tell the another variable. You need only one variable. So that is the meaning of degree of freedom. Fine. Now we are going to check the degree of freedom in the curve COA. So between these only one phase is present, that is in liquid form, right? So what is the degree of freedom for liquid? We will calculate now. Here F is equal to 1, component 1, phase is 1 plus 2. So you will have 2. So you to define any point between this curve, you need both value, both temperature as well as pressure, right? Temperature as well as pressure. This you have to remember. Now we are going to see the another this on vapor pressure curve. Suppose you have any point on vapor pressure curve. So what is the degree of freedom? So you can calculate same way like fusion curve. Here both vapor as well as liquid is present, So both phases are present. So you can calculate here degree of freedom. Degree of freedom on this curve will be the f equal to c, that is 1, phase are 2 plus 2. So minus 2 plus 2 will be 1. So this is monovariant, right? This is monovariant. On the curve is monovariant, and in the middle here bivariant. So to define any system you need both variable, temperature as well as pressure. So what happened to this region O, A, O, B? Below this, what is the degree of freedom? So your component is 1. Your phase, number of phases are 2. Number of phases also 1 plus 2. So here also your degree of freedom will be the 2. So you need to define any point, you need both temperature as well as pressure. Now we are going to see on sublimation curve. So here also you have both phases. So formula is same. So on curve you need to tell only one value, right? So here component is 1, phase is 2 plus 2, minus 2 plus 2 will get cancelled, you will get only. So on the curve degree of freedom is only 1, that is monovariant, right? Now we are going to see this condition, that is O point. Point O, that is we call it triple point, right? Triple point. So on triple point or at triple point, what is the degree of freedom? So all three phases are present, right? So what is the formula for that? 1, component is 1, phase is 3, all three phase are present, like solid also there, liquid also there, and water vapor also is there on at triple point value. So here plus 2 plus 1, it will be 3, 3 minus 3 it will be 0. So at triple point your degree of freedom is invariant. So it's not depend on the any variable, there is no need to tell any variable. So your temperature is fixed here and pressure also fixed. So at 4.58 mmHg and pressure will be there and temperature will be the 0.0075 degrees Celsius. So at this triple point you don't need to tell any variable, so that on that degree of freedom will be the degree on that point degree of freedom will be the univariant, right? So student can note down this. Thank you so much for watching. See you in next video. Till then, happy learning.